Now, this section deals with multiplication. Multiplication can be thought of as the repeated addition of the same number. Here we have 3/8, repeated addition of the same number. So we can abbreviate that by using something called multiplication. 3 times 8, 3 sets of 8. So these are the notation here for it. The operation is multiplication. There's the notation. Sometimes they use parentheses. Sometimes they use a dot. Now that they use an X. It simply means to multiply. Literally 3 times 8. And the result of multiplication is called a product of 3 and 8. All these are ways to say multiply. So here they want us to multiply here. Translate to words. 7 times 6. 12 times 14. This one's 6 times 13. Or you can read it, the result of it would be the product of 7 and 6. The product of 12 and 14. The product of 6 and 13. Now they're multiplying whole numbers here. Modeling it. So they have 3 sets of 8. So 3 times 8 here. This is a multiplication chart. So you can see right here, 4 times 2 is 8. Now there's something called a multiplication property of 0, which simply says that 0 times anything is 0. So here we have 0 times 11 is 0. And 42 times 0. Notice the different notations they're using. It still means multiply. Now this is the identity property of multiplication, which says 1 times anything is a number. So if I have here 1 times 7, I get the 7 back. Or if I have 7 times 1, I get the 7 back. It's an identity situation. You always get the original number back. So this is the identity property for multiplication. Examples: 11 times 1 is 11. And then we have 1 times 42, which is 42. Notice the different notations here. They still mean multiply. Now we're multiplying here. Commute the property of multiplication. Now, in this case here, commute means to move. So the numbers being multiplied can move, but the products remain the same. So A times B is the same thing as B times A. So if I have 2 times 3 here, it's the same thing as 3 times 2. It's the same thing as 3 times 2. Both of them will give me a product of 6. The numbers can change location being multiplied, but the product remains the same. And then it gives an example here of 8 times 7. It's the same thing as 7 times 8, using the commutative property. Okay. Now they're multiplying here in the column style. 27 times 3. So I have here 27 times 3. So I multiply. Notice how the columns are lined up. So I'm multiplying the right things, ones and ones, and so forth. So I have 3 times 7, which is 21. And then I carry my 10. 2 times 3 is 6. 7, 8. 81. Here's another one here. So I have 15 times 4. 4 times 5 is 20. Put down the 0 and carry my 2. 1 times 4 is 4, plus 2 is 6. 60. Now we have multiplying. We have 286. 286 times 5. So I have 286. 6 times 5 is 30. 5 times 8 is 40. 5 times 8 is 40, plus 3 is 43. 2 times 5 is 10. Plus 4 is 14. Let's see here. Mm-hmm. Now they're going to something called the method of partial products. Okay. So with the method of partial products, you multiply to find, you take the product that gives you the number of ones, the product that gives you the number of tens, then you add them together. So, for example, if I have 62 times 87, so I'll put this in column style. I have 62 times 87. So I can see all the changes here. So the first time I multiply, it's going to give me the number of ones. The next time I multiply, I'm multiplying by the 8, it'll give me the number of tens. And then I add these up partially, and that gives me my total. So we have 7 times 2 is 14. 7 times 2 is 14. 6 times 7. 6 times 7 is 42. Plus 1 is 43. Down my 3. 43. And it gives me my number of ones. Now I want to multiply by the number of tens, so I shift it over. So the results will be counting the number of tens. So I have here 8 times 2 is 16. Carry my 1. 6 times 8 is 48. plus 1 is 49. And it gives you my number of tens. 4 and 0 is 4. 6 and 3 is 9. 9 and 4 is 13. Carry my 1. 4 and 1 is 5. So you can see that there. See, 430.